Good evening, students. This is Deekam Pathak from Freebridge Experiences. I welcome you all to this wonderful series called Fun in NCERT. So in today's session, we'll be learning maths from Mr. Abhishek. So without any further ado, let's get started with today's session.
Good evening, students. So in this construction using GeoGebra, I am going to show you how to use the slider tool to dynamically create polygons of different number of sides that are both regular and inscribed within a circle. And then we're going to use this construction to find an approximation for the value of pi. All right, now, so for this, let's just open this GeoGebra Classic. While it opens, let me just remove the excess. So we'll begin by clicking on the slider. This is the slider. And we will name this as M for the number of sides. And let's say we start it at 3 and we'll give the maximum at 250. And let's give it an increment of 1. And you can see and it's a good thing that you press enter after performing every operation, so that you don't start constructing objects that we don't want in our worksheet. You can see from n it can be raised up to 250, right? And the next thing is we are going to construct a circle. Now for constructing a circle, we have different options. Let's go to this circle with centered through a point. We click on the center and then we click at another point. And again, I press enter. You can see out here, I can, just a moment. I can increase the size of the circle. I can move around the center too. I can increase the radius and decrease the radius maybe. So, and the next thing what I'm going to do is reflect this point B around this point A, right? So I'll use the reflect button. Right, this is the reflect button. Now, why are we doing this? So, if we rotate this point on the circle around the center to the appropriate location based on the number of sides in the polygon, so I'm using the central angle of the regular polygon, that is 360 degree, and I'll divide it by the number of sides that will determine the location of the next point in the regular polygon. So if I come up to my toolbar, as you've already seen, right, I will rotate this point B around this point A. The default angle is always 45 degree, right? So let me make it 360 divided by the n and make it counterclockwise, so you can see a reflection. Right? If I, so this is approximately 120 degree, because 360 divided by 3 is 120. So B dash AB is making 120, and you can move around this. You can see as I move around, B comes very much closer to B. Right? So what I want to make is a regular polygon out of this point. So let's make a regular polygon. We will select B and B dash, kind of like an anti-clockwise direction, and the number of vertices will be given as n, which is on the slider. So right now n is equal to 3, so we are getting a triangle. And if I increase the number of n, you can see the polygon will almost become like a circle. Right? Now, pi is defined as the ratio of a circle's circumference to its diameter. So what we can do is take the ratio of the regular polygon, all right, ratio of the regular polygon's perimeter to the circle's diameter, And as that regular polygon becomes a better fit for the circle, so will our approximation of pi. So what I'm going to do is choose this segment tool out here. All right. Now let me just click on A and B dash. So this K13 is kind of like the radius, right? Let me just measure the distance of AB dash. You can see it is 2.638 approximately. And if I click on the polygon, what I essentially get is the perimeter of this triangle. Right? Now on the input box, what I'll do is write down the name which is given for the perimeter. It is perimeter poly1. Right? And divided by the diameter. Diameter is 2 times the radius, which is K13. Now to write down K13, what I'm going to do is write K and then underscore 1 2, because 13 is a subscript. And you can see the value of O, which is essentially the approximation of pi. It is coming out to be 2.59. Now, as we increase this n from 3 to 250, this triangle will almost become like a circle, right? The number of sides increases and it will almost become a circle. And you can see the value of pi out here. It gets a better approximation once we reach 3.141. Cool, right? Now you can make this 1000 also, but I don't suggest because your computer might get stuck, right? It takes a lot of RAM. I tried it once, but you know what happened? My computer just blanked out. So I suggested you can use up to 250. And yeah, this is a small, let's say, construction where you can approximate the value of pi. So in this tutorial, I'm going to show you how to prove the Pythagoras theorem using this GeoGebra. I'm still on the GeoGebra Classic app. The first thing I'm going to do is make a line through 2 points. Let's name it A and B. And then press enter so that we don't construct more. Let me draw a perpendicular line through point B. Right? Now this line G is perpendicular to this line F at point B. Let me take 2 points. 2 points, one on this line G and another on this line D. Right. Let's make a polygon using these 3 points B, B, C. Coming back to D, I'll get essentially a right triangle. Right. Now I want to remove this F and G out here. So what I'm going to do is click on G. Just a moment. And then just check this object so that it gets moved. I'll do the same for F. And let me remove A also. Now what I have essentially is a right triangle, which I can move around, right? Now let's figure out what are the measurements of the sides. For this, I'll go to this measurement tool and click on distance. The distance of B is this, and C is this. Okay? So we are getting some 13 decimal places. Let me just decrease it. Let's make it 2. What I'm going to do is make a polygon out of each side, specifically a square, right? So if CD is a line, right? Its length is 4.15. A square with base CD will be 4.15 whole square, right? So I'll make a regular polygon. Let's click on D and C, and number of vertices 4. You can see we're getting a polygon in this direction. Now let's do the same thing for C and D. 4 and D and B, and vertical polygons out here. And let's check what is the area. Just see this point. And I need the area of this polygon is 17.25. It is 8.25, and it is 9. So basically, CD square is 17.25. BD square is 9, and BC square is 8.25. And you can see this CD is kind of like the hypotenuse. It is the hypotenuse, while BC and BD form the other two sides of this rectangle. We can give this different colors. Some different colors out here. Green. Let's get this blue. Let's get this red. Now, we'll see that the area of this polygon, it is given by text polygon, or we can also use this measurements. Poly 1, poly 2, and poly 2. Okay. So if I just input poly 1, you will get the measurement as 17.25, and poly 2 plus poly 3 in the text box, we should again get the value to be 17.25. Now, how can we prove the Pythagoras theorem is true for every rectangle? What we can do is essentially move this point. You can see we're getting different shapes of right triangles. And over here, this hypotenuse square, which is poly 1, is equal to sum of squares of the other two sides. Okay. This is a small way to figure out the Pythagoras theorem. I hope you can check this out and try to do this again at home. Thank you. Hi students, so in this tutorial we are going to prove the algebraic identity, which is a squared plus b squared plus 2ab is equal to a plus b whole square. Okay. This is a very popular algebraic identity, and to prove this I'll open the calculator suite. Okay. The first thing I'm going to do is make two sliders. So let's take a slider over here somewhere. Let's name it A only. Let the minimum be 1, and let's say the maximum is 10. And let's say its increment is the 1. So you can see, so the increment is the 1 from 1 to 10. And let's take another slider, B. I'll give it the same min and max. And then increment is the 1. Okay. We'll just doing this out here. This is A and this is B. And let's take C under point, another length to be equal to A plus. So you can see A plus B is coming out to be 2. As we increase A, the value of C will also increase according to the changes in A. Right? The next thing I'm going to do is draw a line segment. Right? Click on more. And you see this option segment with given length. Click out here. Click on the origin and it asks for the length. I'll give the length to be equal to C. Right? As you can see, the length of C is 2 out here, and because of that, this segment 2 is of length 2. And if I increase this 5 plus 1, you will get this length to be 6. Next, we can go with 20. Right? Now, let's just make a polygon from this AB, a regular polygon. That is, it will become a square, right? We'll go to this tool option. And then we'll click on this regular polygon. We'll click this vertex A and B. And number of this is 4. We'll get this polygon. Now, this is essentially C square, right? Or we can say this is just A plus B whole square. If I just check the area of this triangle, the square, let's figure it out. We measure area. Let me click on this polygon. It comes out to be 16. Right? If I make this one equal to 2, from 1 to 2, you can see the change. 3 plus 2, 5. 5 square is 25. That makes sense, right? Now, what I'm going to do is I'll click this polygon and I'll just put it out here in the space. And I'll make a length with side A. All right, now the side A is equal to 2. Let me go to the tool option. Segment with the given length. Click on A and let me give the length as. So this AE is basically 2 right now. As I increase it, you see the A is also increasing and the area of the polygon is also increasing. Let me make a regular polygon out of this A. AE, size 4. So we are getting a square with side A equal to 2. So essentially this area should be equal to 4. Let's check if it is true. We'll go to measure area and then click. You see the area of this polygon is equal to 4. Right? I want to construct another polygon, starting with this F, and I'll give its length to be equal to B. So I'll go to this tool option again, and then segment with given length, click on F, length is equal to B. You can see this FH is coming, and FH is basically equal to 3. FH, as you increase this B, so now you can see it has got 6 in it. 1, 2, 3, 4, 5, 6. Let me then lower this thing. And we'll again try to make a regular polygon. F. And then decrease the size. Since B is equal to 2, this polygon should have an area of 4 right now. Let's see if it is the case. It is, right? Now let's make polygons out of the D, J, F, G and F, H, E, B. We just go to the polygon option. Click on polygon D, G, F, G. We calculate the D will form the polygon. And again F, H. Let this case come out here. Let me just remove this K. this function property. Figure out where the k is. We do it like this. All right. Now, again, going back to this polygon option. F, H, 3. So we have to always close the polygon. When we have got this polygon option, let us check the area of this polygon. Essentially, it should be equal to 10, right? The length of A is 5, B is 2. So let's check the area of this regular polygon. It should be 10. See, and this and again outside. We do it in the middle. So you can see the area of this whole polygon is 49, which is essentially A plus B squared. Now, is it equal to A squared plus B squared and 2 times AB? Let's figure it out. Let me first give some colors out of here. Give this green. This to be dark. Yes. And I'll give the same color for this one too. For this area, let me give yellow. And for this polygon, let me give only. As I move the slider, you can see the area is changing. 8 times 4, 32. 32. 4 square is 16. 8 square is 64. Right? Now, what I want to do is figure out what is A squared. A squared is 64. Right? Now, if I increase A, you can see this polygon is also, the area is changing. Right? And then I'll give some B squared, which is 16. Let's figure out what is A times B. This 28. Yeah. Now, O plus U plus V, which is A squared plus B squared plus 2V should be equal to the area of this polygon, which is 121. Let's check it out. O, which is essentially A squared plus U plus 2 times V is equal to 121. Now, as I change the slider out here, as I make it larger and larger, you will see this W will always be equal to this area of polygon, the bigger polygon. Now, the maximum we have given on the slider is 10 on both sides, so we are getting 20, right? A plus B is C, C is equal to 20, so the area of polygon would definitely be 400 on the max side. Yeah. So you can see it's a nice little tool or drill to figure out how this algebraic identity works, which is A squared plus B squared plus 2 times AB is equal to A plus B squared. Hello students, in this drill we will be proving this identity. A plus B whole square is equal to A minus B whole square plus 4AB. Right? This is a popular algebraic identity. And to do this, we just open up the calculator suite. Now that it has opened up, I will use the value of A equal to 12 and let's take the value of B equal to 4. So A plus B should give you 16, while A minus B should give you 8. And to draw a line segment with length A plus B. And let's go to the segment with given length. Click on this origin and we'll give the length as C because C is equal to A plus B. We've already done that. Let's check out here. And so C is equal to A plus B and AB is length 16. Right? Next, we just will break this part down. Let me make a polygon out of AB, a regular polygon, so that I get a square. To make a regular polygon, I'll just click on this option, A and B, select these two sides, and number of sides 4. Yes. Now, just click on the move button. Okay. I'll delete this polygon thing and hide the label. And if we just show the value is coming up to be 256, which is the area of this square, which is 16 squared. Let me make a polygon out of A minus B square. Okay. Now for that, what we're going to do is take this tool to draw a line. Click on E, and let's say this is D. Why D? Because we have already taken D to be equal to A minus B. So this EF is basically 8 of length 8. Let's make a regular polygon out of that. Go to the tool, regular polygon, E and F, then the sides, and this. You see a regular polygon has come up. I will just change and hide this thing quality and let me show its value. It has to be 60. Yes. We can change to 8. Let's make one more. Yeah. Now I can move around this, right? And also let me just bring this to 56. Let me suitably place in the middle of the bigger screen. Right. Now, what I'm going to do is take some points, right, and place the points on this bigger screen. All right. So let me put one point out here, another point out here, another point out here, and another point out here. I am going to make polygons out of this. Okay. Let's see how to make the polygon. Go to this polygon, click on I, D, J, E, I again. So this is one polygon. Let me click on this J, A, K, E. So this is F, and then J again. This is another polygon. Then B, K, G, L. Coming back to B again, one more. And then we have got I, C, L, H, I. Okay. Now you will notice that the area of each of these rectangles would be equal to 12 times 4. Right? You can see from here 4 to 16 the distance is 12. And from this J, it was equal to 4 units. So if I just click check the area, just figure out area, so value, it comes out to 48, which is 12 times 4 essentially. This is also 48. This will also be 48, and this will also be 48. So these are essentially A times B, right? Because we have already fixed our A to be equal to 12, B to be equal to 4. Now, let's check this out. The area of the bigger polygon is 256. We already measured that. Now, let's check the area of the smaller polygon. It is A minus B square. Let me just first write down the C square. So C square is 256, which is A plus B whole square. And let's see what is D square. D square is 64. And if I find that AB is 48. If I multiply it by 4, because 4 such numbers are present, it is equal to 192. Right? Now, A minus B square, that means Q. Right? Q is G square, that means just Q plus R should be equal to O. Let's see if it is correct. Right? Let me just note it down. Here, this C square is simply A plus B square. D square is simply A minus B square. And this is equal to 4AB. And this Q plus R is basically A minus B whole square plus 4AB, which proves the algebraic identity that A plus B whole square is equal to A minus B whole square plus 4 times 18 square. So in this final tutorial, we'll be looking to prove this popular algebraic identity. A square minus B square is equal to A plus B multiplied by A minus B in GeoGebra. Now, what we're going to do is open up the graphing calculator again. Let's open up the calculator soon. Since we've been doing that itself. Now, in the calculator suite, let me just give some value A equal to 12 and let's say B equal to 4. Okay. Now, if I draw a line with, let's say, A, distance A, segment, one more. Segment with given length, we start off with O, the length is A, and then we'll see that AB is equal to 12, right? And, oops, put the button. And for the C, let me remove this. And then another length, another line segment, and let's see its distance is B, essentially get 4. That will make a polygon AB using this AB, a regular polygon. And so this is it, the polygon ABEF. And another polygon, let's say CD and CD. We change the color of the polygons. And then first we remove this label. Show the value, let's say here is 144, and for this one, let me show the value should be equal to 16, right? 4 square. Anyway, let me change the color and effect. Right? I can move around the 16 and let's bring it also perfectly placed on this bottom one. The left bottom corner, the origin. Now, let me strategically put this a point over here. Okay. And what I'm going to do now is make a polygon F H I E, going back to F again, and then G D B I. What I want to do is figure out, first let's give some color Let me give it some red color. Increase capacity. And let's figure out what its value is. It's 96. And let's show the one. 2, 1 is 96. The area is 96 for this one. And let's figure out for this one. Let's give it some color. This color. This is red. Okay. Let's see, its area is 22. Yeah. Now, let me go to this algebra function. The bigger square on it, the bigger square out here, its side would be equal to 144. Its area would be equal to 144. So, which is basically a squared. A squared is 144. And if I subtract it from the smaller square, which is subtract the smaller square from the bigger square, which is b squared, I'll get 128. Interestingly, if you check the area of Q1 and Q2 and add them up, Q1 plus Q2 is also equal to 128. Right? So what we did out here is this whole square, basically, this big square is a square, right? And the small square is b square. Right? And this is the remaining part. This is the remaining part of the square. And we should now check if it is equal to a plus b and a minus b. And we already know just from the diagram that this is equal to 128. Now let's figure out what is a plus b. In this algebraic pattern, if I put a plus b and I multiply it with a minus b, it should also come out to be 128. Cool, right? So this is a nice little trick. Or you can make even a rectangular out of this. A plus b is, will be equal to 16, right? A plus b would be equal to 16, and a minus b would be equal to 8. Let's just write it down. A plus b would be 16, and a minus b would be equal to 8. And if I just make a rectangle out of 16 and 8, well, it would be equal to this shaded region. Right? So which proves the fact that a square minus b square equals a plus b multiplied by a minus b.
Thank you so much, students, for being with us today. So this was the math session, and please do join us again next time. Thank you so much. Bye-bye, good night, and take care.